Now the next topic or next part. Till now we have solved the problems based on Laplace transform. Now the next concept is inverse Laplace transforms. How should apply? If you know Laplace transform, then automatically we get inverse Laplace transform. The inverse Laplace transform depends on Laplace transform only. Nothing is there. We are sending that operator that side. Means one thing you have to remember, this is very important. In Laplace transform, the question they are giving in terms of t. When you are applying Laplace transform of f of t, then we are getting the answer in terms of s. But in inverse Laplace transform, the question is in terms of s, then answer is in terms of t, opposite to that one. Once again, this is very important sentence. Laplace transform of f of t equal to f bar of s means the question in terms of t, the answer is in terms of s. Now L inverse of f bar of s equal to f of t means the question in terms of s, the answer is in terms of t. Now we have some basic formulas like Laplace transform. Then first of all, what I am doing here, whatever I have given Laplace transform formulas, from that one only we are creating inverse Laplace transform formulas. Now observe this one, the basic definition of Laplace transform. Once again, Laplace transform of f of t equal to integral 0 to infinity e power minus st f of t dt equal to f bar of s. Here what I am doing, one side is Laplace transform, other side is inverse Laplace transform. If you want to write inverse Laplace transform formulas, means you have to create the formulas from the Laplace transforms only. Then here L of f of t equal to f bar of s in this definition. Then you send L that side. Then what it becomes, when your L is multiplying here, when you are sending that side, it becomes 1 by L. 1 by L means L inverse. Therefore, the same thing I am applying here, the same concept. L inverse of f bar of s equal to f of t. Means what is the meaning of this one? The question, the first one, LHS side, you observe it. The question in terms of s and the answer is in terms of t. Now, Laplace transform of 1 equal to 1 by s. Then what is inverse Laplace transform? Here L inverse is nothing but, what is that? Inverse Laplace transform operator. This is inverse Laplace transform operator. This you have to remember. There L is nothing but Laplace transform operator. Here L inverse is nothing but inverse Laplace transform. L inverse of 1 by s equal to 1. In the same way, Laplace transform of k equal to k by s. Now L inverse of k by s equal to k. The answer is L inverse of k by s equal to k. The answer is k. Now Laplace transform of e power at equal to 1 by s minus a. Now immediately I am writing inverse Laplace transform of this formula. L inverse of 1 by s minus a means the question should be in terms of s. That's why I am writing like this. L inverse of 1 by s minus a, the remaining thing is e power at. When you are sending L that side, then like that. Again in the same way, Laplace transform of e power minus at equal to 1 by s plus a. Then L you send that side. L inverse of 1 by s plus a, the remaining is e power minus at. Now observe this one, everywhere in you focus on L inverse. Till now so far we have completed Laplace transform. Now mainly you focus on inverse Laplace transform formulas. Now the next formula, Laplace transform of sin at equal to a by s square plus a square. Now what I am doing here, L inverse of 1 by s square plus a square. Then sin at, the extra part is a is available, then you send this side, then what is that? Sin at by a. Means once again you consider, observe this formula. A is constant, that's why we are sending that side. If S is available, you should not send S that side. Now, if you want to observe that type of particular formula, now observe this one. Laplace transform of cos AT equal to S by S square plus A square. Then L inverse of S by S square plus A square. But you should not write L inverse of 1 by S square plus A square. That is different formula. That formula is sin AT by A. Now S is available. Only constant is available. Then constant you can write outside. That like that. L inverse of S by S square plus A square. The formula is cos AT. Now sin HAT. Sin Laplace transform of sin HAT equal to A by S square minus A square. A is constant. That's why instead of A I am writing here 1. L inverse of 1 by S square minus A square. That is sin HAT by A. If it is A is available in place of 1, then simply sin HAT. No need to write sin HAT by A. Now here L inverse of 1 by S square minus A square is sin HAT by A, because A is missing here. Now, Laplace transform of cos HAT, S by S square minus A square. Then inverse Laplace transform of S by S square minus A square, that is cos HAT. Now Laplace transform of t equal to 1 by S square. Then L inverse of 1 by S square equal to t. Now Laplace transform of t square equal to 2 factorial by S cube. L inverse of 1 by S cube equal to t square by 2 factorial. Now Laplace transform of t cube equal to 3 factorial by S power 4. Then L inverse of 1 by S power 4 t cube by 3 factorial. This side is the question is in terms of S. The remaining constant and t variable are answer. Next, similarly, Laplace transform of t power n equal to n factorial by S power n plus 1. Another formula is gamma n plus 1 by S power n plus 1. Similarly, inverse Laplace transform of this function, L inverse of 1 by S power n plus 1. I am not writing n factorial because n factorial is constant. We are sending that side. L inverse of 1 by S power n plus 1, that equal to t power n by n factorial. Otherwise, that equal to, in terms of gamma, t power n by gamma n plus 1, because n factorial value is gamma n plus 1. Like this, these are the basic formulas of inverse Laplace transforms. Then every inverse Laplace transform we are creating from the Laplace transform. That you have to understand the concept actually. If you know very well Laplace transform, then automatically you can solve the problems, inverse Laplace transform problems.